All right. Good morning, everyone. How you all doing? It's a quite a chilly day today in the morning. All right. So today I'm going to talk about linear functions and models. Uh, let me just. So we discussed a little bit of this last lecture, I believe. So there is a bit of continuation from that. So linear functions are everywhere in our lives, from predicting business profits to understanding how long a car will take you to reach a destination. So linear models are very simple tools, but they are very powerful tools. So I'll put down some learning outcomes. So at the end of the lecture, we can assess like how confident we feel in these topics. So how to graph linear functions. And then the second thing we want to do is to be able to calculate slope and the intercepts. So slope and intercepts. And then for the third part, we'll try to apply these ideas to real world problems. All right. So I'll touch on this first, but because like once you know something has practical applications in the real world, you feel more inclined to learn it. So how do you think businesses set prices for their products? For example, Apple recently announced their iPhone. How did they decide on that price? Any guesses? Yes, go ahead.
I believe some make a market survey. So the demand of
the market survey, right?
Yes.
What else? So production costs. Wonderful. Yeah. Are there any that you can think of, or these two cover it? Or
Will it be right to say the average prevailing price of in the market?
yeah, competition. So these are all of the different things that often they are like it's a conglomerate of all of these decisions. So if Android decides to uh, challenge iPhone and they have like a competitive product in the same price zone and they are targeting the same customers, they have to price accordingly. Market server, of course, and so like basically you can distill this to demand and supply, right? And usually demand and supply curves, they are modeled linearly for the simplest things. So, so what is a linear function? So a linear function is a function of the form y equals mx plus c, where m is the slope and c is the y-intercept. We'll discuss what these words mean exactly in a moment. So, so what do you think is the meaning of slope? Mm. So it's like the incline, right? Incline or decline. So slope basically means the rate of change. So in this equation, m means that how x changes with. So yeah, it's basically the rate of change. And the y-intercept, it just means where it intersects with the x-axis. So when you plug in x equals 0, c is the value of the function. So that's the intercept. So let's try to graph a function. So let's do y equals 3x minus 1. Can you guys try to graph this, like roughly?
It got x-axis by 1/3 and y-axis by minus 1.
Yeah, that's fine. We'll discuss it once you're done with your attempts.
How do I graph this?
All right.
Yes.
Yeah. All right, let's do the solutions together and see how we can do this. So y equals 3x minus 1. That's our function in question. So what the graph of function means is you can plot the points that satisfy this equation, and that's our plot basically. That's our graph. So in this function, let's pick up a few points. So what happens when x equals 0? Could you repeat that? Sorry. All right, so wonderful. What happens when x equals 1? All right, and so on and so forth. We can just plug values in and calculate the value of y. Right, so 3 times 2 is 6, minus 1 is 5. So we have a couple of points here. And then on the x-axis, is this x and this is y. You just find corresponding points to it. So we want to find 0 and minus 1. So 0 is here, minus 1 would be somewhere around here. So this is one of our points. And then we go 1, 2. So 1 is here, 2 should be somewhere around here. So go up, right here. This is our second point. Third point is 2, 5. 2 and 5 is somewhere around here. So right here. And then we just join a line that goes through all of these. This has to be a straight line. All right, so this is our curve for y equals 3x minus 1. So in theory, we only need 2 points to make a line, right? So you have 2 points, you can make a line going through it. So you don't have to calculate every point. So a common trick is use x equals 0 and y equals 0, and then just do the intercepts. So do you have any questions?
So how am I able to determine the slope from the ground?
So you're saying if we have the graph, how do we find the slope, right? All right, so if you have these points, you can calculate slope with the formula. We'll just discuss it momentarily. That's our next topic, actually. So slope from this is m equals y2 minus y1 over x2 minus x1. Is that correct? All right, so this is the formula for slope. So if you know 2 points from the line, you should be able to determine the slope from it. You can just plug in this, select this as y1, this as y2, this as x2, x1, and this as x2. and then we can calculate the value of m. Right. So before we discuss this even further, let us try to do a real world example. So as you all know, I'm from the finance background, so I have to discuss a financial application. So stock prices, they often exhibit a linear trend over a short period of time. So today's price is 50, tomorrow is 55. So within a 2-day period, we can approximately say it's going linearly. So let's say the stock price of a company is increasing by $3 per day for a week, and the starting price is 50. What do you think the linear equation would be? Could you repeat that?
3x plus
3x plus 50, right? Right, wonderful. That's correct. So, so this is like a simple linear model. So if the price starts at $50, so what this means, let me just rearrange the variables so it's like easier to see. So let's say P of t. So this means price as a function of time, and 3t plus 50. So what we did was just replace x with t, and t is the time, like the number of days in the week. So on day 0, you plug in 0, the price is 50. On day 1, price is 50 plus 3, 53, and so on and so forth. So let's try to plot this function. So when t is 0, the price is 50. So this 1 point, and say when t is, what's a good number? 10? All right, so 30 plus 50, P of 10. So this is 80. So $80. That 10 go all the way up here. EP. It goes like this. Okay, so let's say, because this is a linear model and this is for stock prices, so we have to make sure that our domain is correct, because it is not going to be linear forever, right? Let's say this model only applies for 10 days. So the graph would only exist like true behavior of the stock in this region, right? So what happens if, let's say, market changes all of a sudden and our slope becomes negative? What do you think the, let's say you have the same equation, but the slope goes negative. Okay, yeah, exactly. So you'll have start seeing downward trends, right? So so that's why, like as we discussed here, like the equation for the slope, that is why that is so important. So let's do a few simple exercises to just calculate slopes and get comfortable with that idea. So we want to find the slope of a line passing through points 1, 3 and 5, 11. So 1, 3 and 5, 11. Right. So let's calculate. So y2 minus y1. So this is x1, y1, x2, y2. So it would be 11 minus 3 over 5 minus 1. So this is h2. So the slope of this, the slope of a line passing through these 2 points is 2. The rate of change of is 2. So, all right. So let's, yeah. Go ahead.
So that's when you were drawing the drawing the line, you clean that side. Why did you clean that side? The graph.
Could you repeat that? Sorry.
So
Uh-huh.
initially, when you drew the line, it went all the way here. It went to the negative side, but you clean it. Why did you clean it?
Or like this line?
Yes.
Oh, so this is like a hypothetical situation. So we were interested in knowing like what happens if some market dynamics change and the slope gets negative. So
No, before you even do the
Oh.
slope, before you did the slope,
uh,
the line that you drew initially went here, went all the way
Oh,
down there.
okay.
Yes,
Yeah.
ended there, but you cleaned it.
all right. So this is where the domain of t comes in play. So t, what is t? Time, right? So can we have a time less than 0?
No, sir.
Yes, not for practical purposes. So
Okay, thank you.
that's why we did that.
Thank you, sir.
Yeah, another planet.
Any more questions?
Yes.
Go ahead.
I wanted to ask you, Prof, when you are calculating the slope,
Mm-hmm.
I see you do y2 minus y1 over x2 minus x1. So what happens if you do y2 minus y1 over x1 minus x2?
Okay, so the only requirement is you have to take so this is like this is our format, right? So y2 minus y1 over x2 minus x1. So this is them. So you can switch these around like y1 minus y2, but you have to flip this two around so that the sign remains one. So let's try doing this here, right? So what if we did 3 minus 11 and then 1 minus 5? So this will be minus 8 over minus 4. It's still 2, right? So you have to stay consistent. So y2 should be here or here, like but you cannot do x1 minus x2. Then you'll get the wrong answer. All right, so let's actually do another problem. So let's say you're a company and you are selling headphones. So your price is 20 per unit for like one your things, and you sell 500 units. So when the price drops to 15, you sell 700 units. So you want to find the slope of your demand function. So let me write this down. So you sell $20 per unit, and you sell 500 of these headphones. And then you have something happens in the market, you drop your price to $15. But then you sell 700 units now. So how do we model this in an equation? So these are like the numbers you get from like a company's balance sheet. And you want to find the demand function and then find the slope of it. So do you have any ideas how to approach this? Right?
I see something like price determining the quantities of food. And from the previous example,
Mm-hmm.
we used the origin prices in time.
Yep.
Model this also with.
All right, you're on the right path. So this is pretty much the same as saying we are given 2 points, right? So we can model this. So let's say X is the price per unit, and then Y is the number of units sold. So we are given something like this. So at X equals 20, we do 500, and at X equals 15, we do 700 units, right? Does this make sense? Right, so so from this we can just calculate the slope, right? So let's say this is x1, this is x2, this is y1, this is y2. Then we can do m equals y2 minus y1 over x2 minus x1. So what's this? 700 minus 500 over x2 is 15 minus 20. How much is this?
That's 40. Minus 40.
Minus 40. Right.
40.
Okay, 40. Did everyone get this answer? All right, so what does the negative slope mean here?
Increasing loss,
That's right.
because the slope is downward.
Are they facing loss? Let's calculate. So if they did this, how much money will they make? So 20 times 500, right? So $10,000. And 15 times 700, how much is this?
10,500, 180.
Right? So they're not making a loss by decreasing the price
Oh, yeah.
because because the demand increased, right? So it is not a direct relationship. But what the negative slope tells us is for every dollar they decrease the price, the demand goes up by 40. So this is like a neat way to interpret these things.
Please.
Yeah.
Again,
Mhm.
repeat it, please. What does it mean?
Okay, so the initial why we did this calculation is like you cannot directly tell if the company made a profit from its demand curve because you have to actually calculate the values and find the values. Okay, so what negative 40 means is what you were asking, right?
Yeah.
So what negative 40 means is the equation for this curve would look something like this, right? So y equals mx plus c. That's the general curve. So we do y equals minus 40 plus c. We want to find the y-intercept, right?
30x.
What?
Oh, yeah. Thank you. 40x plus c. And now we want to find the c value, right? How do you do that? Right?
Taking out
Yes, we just plug one of these values in, right? So 500 equals minus 40 times x. So x is 20 and then plus c. So from this we get minus 800. Put this on the other side and then c. So c equals 8, 9, 10, 1300. So our equation now is y equals minus 40x plus 1300, right? So what this minus 40 signifies is, let's say you start with 1300 and then go 40 every time you decrease the price by $1, right? Okay, so let me just plot this so it might be a bit easier. So I'll not be exact, but a negative slope, what does it mean? It will go down, right? So it goes something like this, for example. So if this is the x value, this is the y value. So what is x? X is the price per unit. And what is y? Y is the number of units sold. So as soon as you decrease the price from, let's say, okay, so this way the price is increasing, right? So let's say this is 1, 2, 3, so on and so forth. And this is 1, 2, 3, to get to like some big number. So as you increase the value of your unit, like 1 unit is like, let's say was $20 a unit, then you increase the value to 25, let's say, for example. The demand drops because less people want to buy it. Yeah. So a negative slope means if you increase the price, your demand is going to drop, and if you decrease the price by 1 unit, $1, you see the reverse trend, right? So if you were $3, it was here, or $2, you have like a bigger number. So yeah. Any more questions? Yes.
It's the price, that was X, has a unit of measurements. And then the Y also has a unit of measurement. When we calculate the slope, should the slope have a unit of measurement? Or we should just leave it like that? If it's a test or exam, should we mark it for it?
Oh, slope usually because X and Y could be anything, right? So let's say in a physics class, you might see like let's say time and then distance, right? So something like this. When you calculate the slopes, what it does is, so let's say slope is what? For this case, it would be y2 minus y1 over x1. So let me just keep it consistent this way. So the slope is y2 minus y1 over x2 minus x1. So this is the formula, right? So, but y2 could have any units, right? So let's say this is distance, so it could be meters, and this is time. This could be seconds. So you'll have something like a number a minus b in meters, and then you'll have say some time t2 minus t1, that would be in seconds, right? So your slope would be in meter per second. So in most of our cases in the test, since both of the things are in same units, it usually cancels out, but it might not be the case everywhere. Yes.
So why do we take X as the price per unit? Can't we take number of units sold as X?
Yes, we can do that. The graph would just be like a pyramid because these things, the graph will just look different. So let's say what happens when we do that. So imagine we take X as the number of units sold, and Y as the price per unit. So if you do that, your graph will just look different, but it is used to, so it would be 520, so 520, and then 715. So we would do this when we are interested in finding, so this is the number of units sold, and this is price. So if you want to know how does changing the number of, like you are the manufacturing team and you want to find an optimal number of how many units you can produce and without dropping the price, something like that. So then you would be interested in this type of curve. So you put this on the x-axis. So you can exactly do that, but it shouldn't matter too much. Like it depends on what you're interested in finding. Does it make sense? All right. So we already covered intercept, so I'll skip this example. All right, so let's do.
Question.
Yes, go ahead.
So if we're asked to discuss our equation of the line, so what are we supposed to do? For example, the rate, we are asked to find the equation of the line of some given units. and we get to our equation, we have to discuss it. What is required of us? For interpreting.
Okay, so you're saying, let me understand what you're saying. So let's say you're given something like this, right?
Yes, we are asked to find a relationship between them. And suppose we are done and reporting an equation of a one,
Mhm.
and we have to discuss our results.
Okay.
What are we supposed to do?
So let's say you're given these things, right? So you do all this stuff, find the slope, find the equation, and you get to this. So you are interested in knowing how to interpret this, right? So for the plots, the graphical representation of a linear equation, you can. So what this does is tells you. You can just plug this back in, right? So let's say this is the equation, right? So this is an abstract mathematical form, right? So a business person might not get it. But then if you do this, so number of, you just replace the sold equals minus 40 times price per unit plus 1300. So this 1300 means that if you plug 0 in here, right? That's the number of units you sold. But does that make sense?
Okay, so if you do the batch to 7, we're gonna get 1,200.
Mhm.
That means we're not saying.
Yeah.
So how?
Okay, so this is like a strange phenomenon. So what happens is the price per unit, let's say your plot looks something like this, right? So at 0, right, you get 1300. And at you go something like this, right? So this is the base function when you start. So because most of the times we are interested in finding like a certain range. It barely covers the entire line, right? So if you say linear function y equals 3x plus 2, you want to specify x every time, like the domain, because this covers the entire real line, right? As you know. So let's say it goes from like minus infinity all the way to plus infinity somewhere. So what happens is you have to explicitly specify like what range of x is or what input variables you are interested in. So this equation we get, right? We cannot put x equals 0, right? Like, how will you be profitable if you sell it for free? Like, if you give it for free?
Maybe I'm an NGO.
Well,
I might give things for
mhm.
So
But how will you make profit? Like, you have to think as a company, right?
but NGOs are not so, they are more focused on funding partners. It depends solely on funding partners or the society for contributions to run their programs. So maybe price can be 0 at that time. And maybe after some time, if sure maybe there's a need, we can be changing the prices from 0. Started at 0.
Okay, so all right. So what this 1300 means is basically it is the fixed cost here. So it doesn't mean that if you don't sell anything, you'll make 1300. It's the fixed cost you'll always have.
The cost of the production.
Yep. Exactly.
Or even what's the building, like how much
the rent is, or something like that. Yeah. All right. So the next example kind of touches on the yes, go ahead. So
how is it fixed? See, the equation is number of units sold.
okay.
So how is it fixed?
So oh no, so we are expressing the number of units sold as a function of how each unit is priced, right? So look at this here. So this is our equation, right? So x, we are trying to do this. So y as a function of x, right? So y could be anything, right? So the number of units sold as a function of price per unit. Does it make sense?
Yeah, so if it's zero, number of units sold,
Mhm.
2,300.
No, and the price, like, so even before you start selling, you already have some products being kept. So the number of units that you're going to sell, you're going to be selling is going to depend on the price of the commodity. And then the price is going to be the variable cost and then, like we did last week, like the variable cost and the fixed cost. So there's already a fixed cost attached to the price.
Yes.
So going to
So
affect
we
what you are
have
selling.
X plus 40,
Uh-huh.
then the number of units sold will be the negative 300.
Yes. So that's why we are interested in like defining the domain of x, right? Because the linear function, it just expands from like all the way to positive, negative, right? So at a certain threshold, you start getting negative values for y, right? But like in a equation like this, where we are like actually interested in finding the number of units versus the price per unit versus the number of units sold, we cannot have negative values. So that's why like we have to define like what area we are interested in, right? So yes, exactly. What he said is once you get below a certain point, you'll start getting negative values for y, right? And that doesn't make sense. So we have to explicitly define like the domain we are interested in. All right. Yes.
I have a question. In relation to the X, you said that if we find the slope, you write it as the units, so like the example you gave, you write it as meters per second.
Mm-hmm.
But the question we have price per unit. Wouldn't that be like the slope?
Price per unit.
Yes.
Yes, that could be a case, but that will only happen. So let us, because like in general, slope could be considered like a tool to assess the rate of change. So let me know if this is what you're asking. So you said $20 per unit. If this is given, can we consider this as slope?
No, like you see, we are looking at price and the quantity sold, right?
Mm-hmm.
So I really am thinking that the X should just be price and not price per unit. So the price per unit is like we've already found the slope, so we have to find the price from this.
Oh, okay. So yeah, I get what you're saying. So you can say so this is all like one thing, right? So it's not let's say this is given, right? So you sell 700 headphones at $20 each. So $20 each is just what that is meant to signify. It could be like you can define the limits of how that works. Right? Does that answer your question?
So should we just write price instead of price per unit?
Yes, we can do that. Yeah, that could avoid confusion. Yes, thank you. All right, so let's do a simple another example, staying on the as William mentioned on the startup ideas. So let's say you start a business and the fixed cost is 500 for rent and marketing, and $20 for each product you produce. So what would the cost function look like? Yes, let me just write this down. So So you do the fixed cost is $500 for rent and marketing. And then you charge the $20 for each reduction unit. So what would the cost function look like?
That's 500.
28 plus 500. Is it everyone get the same answer? Right. So let's say this is y. Like conventionally, this is also written as C of x, so cost of x. All right, wonderful. So, what other things could be considered as fixed costs, like in real world for a business? Okay, so for this case, rent and marketing was considered our fixed cost, right? So let's say you start your own business and you want to make sure, like, what are your fixed costs every month or every year? So what are some examples of fixed costs in real world?
Cost of plant and machinery.
Repeat that.
Cost of plant and machinery.
Yes, exactly. All right, some more. What's that? Transportation. Is that a variable or a fixed price? Yeah, it depends. Yeah, in some cases it could be. Right.
Electricity cost, salary of
Mhm.
the employees.
Right. So usually the things that are fixed, they're like related to infrastructure and materials, right? So pretty much everything that you spend in acquiring those, or that you have to like that you're on a yearly contract with, like rent, lease amounts, stuff like that. Mm-hmm. So yeah, those are like some great examples of. So let's do another example. All right. Does everything here make sense? Right. Right. So we'll do a demand function for our product. We did cost functions. Function for a product. So this is an example from the book. So let's say you run a supermarket and you sell beans at two different prices. So the first is, let's say, price per can. So can of beans is the target product. The price per can and then demand. How do you assess demand in the supermarket? Like if you want to order some product next time, like
It's dependent on price.
So final stock minus your initial stock.
no, like just in practical terms, let's say you're running a supermarket, right? And you have some products. So which product do you restock the most?
The one
Now
now.
they put high values.
Yeah, the one that sells the most, right? So what you can do is like assign a unit. So you do like some amount of units sold per week or per day, and then you can model from there. So let's say the first kind of beans, they are priced at 50 cents, and the second is 75 cents. And these sell 400 every week. And then these sell 350. So if you want to make like a demand curve, how we do that? You say aloud.
Yeah, it will be down.
So the XY thing, the points,
Mhm.
and just a line.
Yep, exactly. It's the same thing. Just the name changes from cost function to demand function. It's the same thing exactly. So let's say we want to do, let's just find the slope, right? So m equals y2 minus y1 over x2 minus x1. How much is this? Can someone calculate this?
$100.
Okay.
Or minus
Minus
minus 20.
okay, minus 200. Well done. So this is our slope. Negative slope again says like if you increase the price, your demand is going to go down. So this is our slope. Now we find the equation for it. So y equals mx plus c is the slope intercept form, and then you plug it in. So y equals minus 200 times x plus c. So let's plug this pair in. So x is 0.50, y is 400. So 400 equals minus 200 times 0.50 plus c.
Oh, you need the X.
Do you have any questions?
Yes.
Yeah, go ahead.
So in a demand trend,
Uh-huh.
demand is X, price is Y.
Yes. Yes.
As in our case, they're taken.
So, like, just to be clear, like, for many of these things, so let's say this is demand and this is cost or price. So, let's say your plot looks something like this, right? So, as you, so in real world, let's say you have, let's say a product is priced at $500. You have 1 point, and if they decrease the price, let's say the PlayStation goes on a 50% discount tomorrow, and the price is $250. So you expect the demand to increase, right? So if the price decreases, the demand should increase, right? So if the price is $250, so it decreases. So when you flip this, you have the same thing, but it just tells you different things. So price and demand. So if the PlayStation price was $500, your demand was somewhere around here. Now they decrease the price from 500 to 250, let's say. The demand increases, right? Did I do something wrong here? So, like many times, it often just says the same thing. You just flip the axes around. So, if you're interested in like knowing, this is usually the thing that we have, right? And this is the y-axis. So,
Question.
Mhm.
Because if we calculate the slope, there are various slopes. It's gonna be reciprocal. The slope of the second graph.
all right.
will be the reciprocal of the first.
Mhm. But then your C values will also change, right? All right. So let's do this practically just to make sure. So what would the C value of C from here would be? Yeah, that's correct. So this equation is y equals minus 200 x plus 500. So how will our equation look if we flip these around? So let's do that. So let's say y x. So now our new slope would be what? Let's say m1 m0 equals minus y1 x 2 minus x1, but our x and y's are flipped. So it would be 0.75 minus 0.50 over 350 minus 400. So it would be minus 1 over 200. So now our new equation would be what? Say y equals minus 1 over 200 x plus c. So let's say our new c would be what? What values can you plug in for y? So let's say 0.50 equals minus 1 over 200. 400 plus c naught. So this is 2. So c naught would be 2.50, right? Is that correct? Take 2 on that side, becomes positive, and 2.50. So our new equation would be y equals minus 1 over 200 x plus 2.50. So what was your question again?
Yeah, there are two different equations.
Yes, because in this case it looks similar, but the equations would be different. It could be transposed a bit to the left, right, or angled somewhere else.
So in somewhere, this question was given and the two different students presents. One presents this, and one presents that.
Yes.
Is it going to be back and forth?
No, so you'll be explicitly stated like what you have to find, because for example, we want to find a demand function, right? So demand function is this one, not this one. This is the so what this tells is the dollar values versus like, so it's just the opposite way around, right? So price per can versus demand compared to demand versus price of each can.
So this is rather the demand function. That's the other one, because demand function prices y quantities x. So it's supposed to be this one. Sorry.
Yeah, so what this means is for every cent that you increase in price, the demand increases by 2. So we already covered the fixed cost. So all right, so let's do one more example, but this is from the this is like the time distance curve, so from physics. So linear models are very good for doing distance calculations in physics. So let's say you're driving at 54 miles per hour, right? So let's say your speed is 54 miles per hour. And this is a rate again, right? So every hour you go 54 miles. And let's say you're driving on this. This is your house. And this is work. And you start driving from here, and then you walk, let's say 20 miles, or let's say 2 miles, and then you took a scooter or something, and then started driving from there, right? Yeah, that would, yeah. All right, so you just walk 2 miles out from your home, and then let's say you get a bus or something. So you get a bus here, and then the bus drives 54 miles per hour, and then you go all the way through. So we want to express this situation in an equation in terms of time t. So how can we do that? Any guesses? All right, so let me just repeat this just for clarity. So you start from 0, you walk 2 miles, then take a bus, and then you're driving, like the bus is driving you at 54 miles per hour. So we want to model this in an equation. So how can we like find parallels to previous examples? So can we say this is like a fixed part of the equation, right? So let's say 2 plus, and then we are changing at 54 miles every t time. Right? So yes, 54 t, exactly. And this would be just, let's say, for example, s of t, distance as a function of time. So this is our representation of this physical situation in the mathematical form. So this is what linear modeling is all about. So let me ask you all a question. So let's say you are driving from point A to point B, and then the distance between these 2 points is 500 miles. So let's say you drive 60 miles per hour, your speed. This is a different question, by the way. 60 mph. So when you what time it would take you to reach point B? Like how long does it take? Right, so you're saying 500 miles divided by 60, right? So that's our time. Everyone knows this, right? Speed equals distance over time. So yes, exactly. But then these things come in play. Let's say you are doing a road trip and then you decide to stop for 2 hours. So then you'll have like an +2, right? In like this is the time you be on road, and then 2 hours extra that you are like this standing still. So this is like a good visualization of the fixed cost in terms of business. So so let's go back to the objective. So did we learn how to graph the function, right? We're confident in that. So do you know what a slope is? The rate of change. What are intercepts? Someone give me an answer. Yeah. So where the values of x is 0 or y 0, and so when x is 0, it is the y-intercept. X equals 0 gives you y-intercept, and vice versa. So y equals 0 will give you x-intercept. So we know this. We did some kind of real world problem, idealized real world problems. So and that should cover most of it. Yes.
I know that this is a trivial question,
Uh-huh.
but in your examples, you were taking us through physics business. Is there an intersection between the physics and business?
Linear models are used pretty much everywhere. So whenever you have 2 points, you can make a linear relationship between